Okay, everyone, we'll go ahead and get started. Thank you for joining us today. My name is Kara Gordon. I'm the Partnership and Communications Coordinator for ECU Center for Sustainable Energy and Environmental Engineering. I'd like to welcome everyone today to our second webinar in the Fall Pollution Prevention mini-series. At the center, our mission is to promote renewable energy technology and natural resource conservation through scholarly and applied research in an effort to enhance industry awareness and best serve North Carolina communities. With research funding through the EPA's Pollution Prevention and Source Reduction Assistance programs, center students, faculty, and affiliates provide valuable resources to businesses and industries across North Carolina. We offer energy, P2, and lean assessments and training largely to North Carolina automotive, chemical, fabrication, and food and beverage manufacturers. After conducting a facility assessment, the center additionally provides technical feedback and various business analyses. We also facilitate certification workshops for sustainable and green manufacturing, most recently the Lean Six Sigma White Belt certification. Before I introduce our speakers, just a little housekeeping. We are recording today's event. Please reply to the follow-up email that you will receive from me after the event for access to our shared library. You will also find our presentations in that shared library. They've also been uploaded here on the Teams platform if you're able to see that. We have run into some difficulty in sharing institutional cloud data with .gov and .organizational emails. So therefore, you may want to share a personal email address with me to be able to access that file. We encourage you to interact with our speakers. We'll take questions at the conclusion of presentations, time permitting. You can also drop your questions into the chat at any time, and I can ask for you. At the conclusion of this webinar today, you'll receive that follow-up email from me asking to provide feedback. If you could just take a moment and tell us how we could improve future events, that would be helpful. Thank you. The email will also provide a link to be able to donate to the center. We gratefully appreciate any contributions that are given to us as they help us support student activities and community engagement. So with that, I'd like to introduce our first speaker today, Dr. Tarek-Salam. Dr. Salam is a mechanical engineering professor and associate dean for research in the College of Engineering and Technology at ECU, and he currently serves as our director at the center. Before pursuing his doctoral, if I could get someone to mute themselves, please. Thank you. Before pursuing his doctoral degree in the mid-90s, he was an environmental engineer with the Energy Conservation and Environment Project at Cairo University in Egypt, where he was involved in more than 60 pollution prevention diagnostic assessments among several industries, including Egypt's tourism industry. Dr. Salam served as project engineer for the Industrial Assessment Center at Old Dominion University and conducted 24 energy audits a year as an ISO 14000 auditor. He also taught environmental management and hazardous waste management courses at the graduate level. His research areas include alternative fuels and environmental management, energy storage, and renewable energy. Thank you so much for being with us today, Dr. Salam. We appreciate your time. After Dr. Salam, we will hear from David Mayo. David is a faculty member and director of the CRISP Small Business Resource Center in the Miller School of Entrepreneurship here at East Carolina University. He received his undergraduate in marketing from North Carolina State, then received his MBA here at ECU. David has worked with hundreds of small businesses and entrepreneurs in the community, assisting with capital raise, marketing, innovation, and strategic planning. He's also helped start several consulting, manufacturing, and web service companies. He directs North Carolina's largest pitch competition, the Pirate Entrepreneurship Challenge, with 400 participants and over $150,000 in prizes. He also serves on 3 nonprofit boards for small business support and multiple boards of directors and advisory boards for North Carolina startups, all in an effort to enable businesses to grow and thrive, particularly in rural communities. Thank you so much, David, for your time and expertise today. Oops. So with that, I'm going to go ahead and turn it over to Dr. Salam.
Okay, I'm just trying to share screen. Okay, do you see my screen now?
We do.
Okay, good. Okay, so good afternoon, everyone, and thank you very much, Kara, for the introduction. And it's really my pleasure to be part of this webinar today. Talk about something I've been doing for probably close to 30 years right now. Talk about pollution prevention and source reduction. So I will simply start by quick overview, just a quick or brief definition of what's pollution prevention, and talk about some concepts briefly, and then show some examples, and then David will take it from there and talk about the most important thing, which is money savings and cost benefit analysis. So this would be how I'm gonna really present today. I think I have about 15 to 20 minutes, so I hope I can really cover enough materials within this time. So this is how we define our traditional definition of pollution prevention, like the use of materials, processes, practices that reduce or eliminate the creation of pollutants or waste at the source. So that's why also they call it source reduction. It will save and reduce the use in different areas. Materials in general, like raw materials, not just hazardous materials, raw materials, hazardous materials, energy use, through energy efficiency practices, water use too. I'm going to talk about this and give some examples about the energy and water and chemicals. So this
Hello,
actually
Tarek.
very, yes.
Can I interrupt you 1 second? You're in presentation mode. We're seeing your notes. You mind swapping displays?
Oh. So what I do, okay, this way?
No, go back and go back into present.
So where is present, Randall?
You can go to the bottom right or start your slideshow.
Oh, this one?
Yeah, that one should work.
I think I know. So sorry about this. Okay, this now is working. Still?
In the upper left, click swap displays.
Okay. Sorry about that. Where is it? Upper left? Swap displays. What about
there? We go. Thank you.
I didn't have anyway a lot of notes, but thank you for helping. So I was actually here, right? So anyway, I was talking about the pollution prevention and the cost savings that really accompany or attach it to the pollution prevention practices. And this is actually well known. I have the, of course, black and white figure here. This is something I like to show all the times about the hierarchy of the pollution prevention. First thing we start with is source reduction and pollution prevention to reduce waste, and that's what we recommend most of the times to people in the manufacturing facilities. If before you do anything or make any changes, start by implementing source reduction and pollution prevention practices. And you see the priority here from high to low. So we start with the source reduction followed by reuse and then recycling and treatment, which is not really part of what we recommend when we go and do energy assessment and pollution prevention in facilities. In general, pollution prevention can include anything, as you see, from fixing leaks, very simple stuff, to actually process modification and material replacement. It can also be low cost and high cost strategies. The implementation, which is the major and most important part of pollution prevention, also varies from easy to difficult in implementing these recommendations. I can give some examples here quickly, simple stuff that won't cost money and will highly reduce the waste and make a lot of savings. When we used to go in the 90s and look at the electrical or we call it static painting or powder coating, something very easy, grounding. If you have poor grounding, you end up having a lot of overspray and actually the quality of the paints won't be good or sometimes won't be acceptable and end up having excessive waste. And this is just because of grounding. So just fixing this problem, the solution is easy. Fixing the grounding problem will save you a lot of money. Also, this powder cannot be reused. So the powder that's in the ground, you have to collect, you have to get rid of it. It cannot be reused because it's already charged. By just improving the grounding and by just doing this, you save a lot of money and reduce the waste. And this is probably a clear example of the pollution prevention. Something else related to metal finishing and metal fabrication, electroplating and chemical tanks, reducing the drag out from the tanks. There are different ways, and all of them are simple, low tech, and very, very low cost. Could be no cost to low cost. Example of low cost, just install drag boards. So when you do electroplating, you put the metals in the chemical tank or the process tank. When you then remove it from the tank, one way is to extend the time so the droplets will go back into the process tank. Just expanding the time. I know this is difficult in some processes because they don't like to leave the products in the air for a long time. But by doing this, you put the chemicals back in the process tank. And also the next step in any of these electroplatings would be rinsing. So if you take some chemicals from the chemical tank or the process tank and put it in the rinsing tank, actually you contaminate the rinsing tank. And most of these tanks used to be overflow. Just doing simple technique, you can save a lot of money, chemicals, and also reduce the contamination of the rinsing water and reduce the load of the wastewater treatment if the facility has wastewater treatment. There is more than this, and static rinse tank, collecting tanks, where you can collect these chemicals and put them back on the process tank. So these are some practices that can be easily implemented, reduce pollution and save money in the same time, and it won't affect the quality of your products. So I know many people are interested about the quality. Their main concern is keeping the quality of the product and the cost of the product low and the quality high. Here's another example, and this is something I like to show every time I talk about source reduction and pollution prevention. The weight of the 2-liter soft drink bottle. According to this source, it was 68 grams in the 1977, and now or recently it's about 50 grams or 51 grams. This might be a small amount in mass reduction, like 17 grams. What's 17 grams? But if we know that the production of soft drinks is about 34 billion gallons a year worldwide, and the United States just is consuming 25% of this. Not all of them are 2 liters, of course, but some of them are 2 liters. So there are sources showing that by just reducing the 17 grams from the 2-liter bottle, you save 100 or millions of kilograms of plastic per year. That's really a source. We can consider this to be source reduction. So you eliminated the use of the materials and you save money because, of course, you don't pay for raw material to make same amount of money to make the same number of bottles. You pay less. As I showed in the definition above, we have also energy and energy efficiency, and could be considered also one of the pollution prevention practices or source reduction, just eliminating the use of energy. These are the common areas in many industries, like chillers, cooling towers, compressed air systems, boilers. These are the major areas. Also, we can have furnaces. To add it to this, lighting, of course, ventilation system, HVAC, etc. Some recommendation, these are big systems, but some recommendations can be also very easy, straightforward, no cost or low cost. This can be, if we look at the boilers, we can just simply recommend tuning up. Just by tuning up the boiler, you increase the combustion efficiency, you reduce the consumption of gas if they use natural gas or any type of fuel, save the environment, less air pollution. In the meantime, you save a lot of money just by reducing the gas consumption. I'm going to show you one example after that. Also, in compressed air, for example, compressors, fixing leaks, reducing the operating pressure of the compressors, using synthetic oil in compressors, having maintenance plan, using V-belts or efficient belts. All of these recommendations now are well known. So this actually will have a big impact if you look at or consider all of these simple practices. You end up having good savings and efficient, I would say, use of the equipment. So that's for the energy part. Now I'm going to show, that was quick introduction about source reduction and pollution prevention. Now I'm going to show some examples about pollution prevention, and in addition to also some examples about energy savings. I chose one example, fabric dyeing, because I did this audit in the, I would say around 1993, 94. One of the big facilities, I choose this example because it's a big facility, so you see clear impact of implementing pollution prevention, and the concept was relatively new at that time. So I choose a fabric dyeing and finishing facility. This is a big facility with a lot of water and steam consumption. I think the boiler, they use a boiler in this facility that generates about 6 tons of steam per hour. And this is really huge size of boilers. And their production, they consume 37 cubic meter per hour. This is like 90 or 10,000 gallons per hour of water, in addition to the steam. So per day, we can say we have about 450 meter cube of water used per day. So of course, this will open an opportunity for us to jump in and suggest some savings. When we introduced this technique, was relatively new now, people are aware. We're still recommending reusing water and still just this type of recommendation working fine. This facility is a huge facility, as I mentioned, and what you see right now is just 2 washing lines. So they have in their production line 2 washing and rinsing lines. One is 8 steps, one is 6. So I'm going to talk about the 8 steps. The one in the left, this is the flow chart we used to do when we audit the facilities, do the environmental auditing for the pollution prevention. So you see in the left, we have the material, we have caustic soda, we have agents, we have chemicals, we have also the company used originally some circulated water from the last tanks. This process has 8 tanks. So the fabric is coming from top and leaving from the bottom. So you start with washing, 2 tanks for washing. You see the temperature is 95 degrees C. So it's not just water, it has heat on it. The wastewater here will be just by dumping the 2 tanks frequently every day into the sewer system. They have wastewater treatment, of course, so they have to treat this amount of water. But the rest of the tanks, the other 6 are overflow, so the water is running continuously. And as you see, also the third tank is about 70 degrees, fourth one is 60 degrees, 50 degrees. So most of them are being heated by the steam. The company at that time was actually they were using the last three tanks, the water from the last three tanks, and putting some of this water back into the washing tanks because this water is usually clean. And this practice, by the way, can be used also metal finishing when you do degreasing and surface screening or pre-treatment before you do painting or before you do electroplating. So this concept could be used too, because we take the last tank, which has the cleanest water, and then move it back to the first tank. So this is a sketch of the current situation at this company, and that's what you see right now. So what we see is just taking the water from 3 tanks, 6, 7, 8, and put it back onto 1, 2, 3. So what we recommended at that time is 2-stage. So taking the water from tank 8, put it back to 7, and then back to 6, and then let it go to the wastewater treatment, and then start at 5 and move it to 4 backward to, and then 3. The reason we do this because these tanks were actually running by overflow. So there's overflow, continuous flow of water. And by doing this, we reduce the consumption of water severely, big consumption. Reduced just by implementing this. And we kept the quality of the product the same because that was the concern of the company. And this is just water now. We reduce the water, and the water has some chemicals contaminated with some chemicals too, which needs to be treated at the wastewater treatment. So we reduce the load of the wastewater treatment. We reduce the chemical load. We also saved some energy here. It's clear because these tanks, they have 50, 60, and 70. They are actually hot or warm water. So there was some energy savings. And of course, I'm not showing any calculations here, but these are done and showed a lot of savings. What I'm showing you now is just summary of the table of recommendations for this company. Not everything we recommended at that time. So the water, reuse of the water is the one in the middle. So we were able to reduce about 7,000 or 7,600 meter cube per year, and reduce of course, the wastewater treatment load. And we reduce about 61,000 natural gas. Other recommendations here, implementing revised print shop, that's pollution prevention. This actually is another option. It's really, I need time to talk about this, but by implementing something like this, just having different practice or implementing something new, you say reduce the biological oxygen demand, total suspended solids, COD, etc. And the last one at the bottom is just replacing one technique with another technique. So we replace the technique used with and replace the chemicals with hot caustic chemicals at that time. It also gave us good savings. And as you see in the left side, this payback period in the right side is less than a year, 11 months, 8 months, 7 months. We see this a lot in big companies. We don't see this in small companies. So the impact always in big companies is big. I'm summarizing the findings for this facility because we were able to reduce, by implementing the pollution prevention and source reduction, we were able to reduce the chemicals, total suspended solids, biological oxygen demand, carbon oxygen demand, reduce the discharge to the wastewater, reduce the dye to the wastewater, etc. Reduce the use of steam, reduce the water. So as you see, it's mostly reduce, eliminate. So that's the first part of the hierarchy of the pollution prevention and source reduction. Now I'm moving to another application, and this is probably something you're going to see in metal fabrication, metal finishing, where you can really minimize, and chemical industry too, where you can minimize the cleaning of equipment and parts. The picture is showing just pressure washing, but this is not really what I'm talking about. I'm talking about chemical tanks where sometimes you have to do stripping, and this will probably require more labor and more time to strip a tank. So there are different techniques for just eliminating this probably way of cleaning. Like one of them is minimizing the need for cleaning. It could be implemented in breweries and wineries and multiple applications, so not just metal finishing, by having the same product probably in the same tank. So this we'll have to look at the production and the plan for production. Another way is high pressure washing, but not the one you see in the picture, actually like modifying the tank from inside and having a system that can apply high pressure from inside and have drainage at the bottom of the tank. So it can really strip the chemicals from the sides of the tanks. Use waste solvent for flushing from a different process. We can use the waste stream from another process to clean some of the tanks. So these were some of the recommendations for chemical and metal fabrication facilities. Last two examples will be about wineries and breweries, because in North Carolina here we have nearly about 200 wineries. Was about, I would say they produce almost 2.4 million gallons of wine a year. And the process is a typical process in most of the wineries. So you have destemming, crushing, fermentation. It requires some heat, some sterilization. So it is related to pollution, related also to energy. So there are a lot of potentials here. If we look at the energy consumption in a typical winery, based on the published research, 38% of the energy is consumed by the HVAC, including the coolers and the freezers, refrigeration system, lighting and sterilization. The last one is 12%. Refrigeration system is about 22%. So this is just a rough estimate or average estimate of how much energy or the major energy consuming units in a typical winery. So these are the areas we look at when we go and audit a winery. Some savings related to the pollution prevention and lean practices will be in the fermentation process, mainly, and filtration. These recommendations could be or will be made just to eliminate the waste of the final product, because they have a lot of spillage moving from one tank to another tank. The recommendations could be very easy. Just have a system of pipes or tubes and move by using a pump, and that's what you see here in this figure. So it installs just a piping system to move from one tank to another tank, will eliminate the waste of the final product. I forgot to mention, this example is for a small winery. So now if you look at the right side, you say that the payback period now in terms of years, not months like the big company. But in the meantime, we are saving the environment. We are making savings too, but the payback period won't be fast like the big companies. Number 3 here, and I was interested in showing you this, they use well water. So we cannot estimate a lot of savings because the water is coming from well, but it is actually saving the environment. So they were actually at this winery, they were very, very interested in implementing most of these options, not just to save money, but to apply the pollution prevention and save the environment. Another example here, this would be the last one, expected savings in breweries. Also North Carolina, here we have about 360 according to the statistics in 2020, about 360 breweries. Most of them are small size breweries like the winery I showed you. So also, and you see this in the picture. So the savings won't be much, be a lot of opportunities, but not a lot of or fast payback. Some of the recommendations we make, quick ones, like install variable frequency drives, boilers. They have small to medium-sized boilers. This is typical in breweries. Lighting, installing solar panels, skylight for actually to reduce the energy consumption. What we notice in North Carolina is many wineries in the mountain area are using or installing solar panels. And now we are just promoting this to encourage breweries also to install at the rest of the state, install solar panels. We provide detailed information about the savings, and once we are done with the assessment, we also make something called follow-up documents and implementation documents, provide everything we can to help the industry to implement. And that's what David is going to talk about next. Savings here related to pollution prevention, not related to energy. Just to reduce the waste of the grain and the raw materials. Usually this type of practices will have also probably much or more savings, but same payback periods in terms of years because of the size. The last thing I want to really conclude with is now, if you want to implement pollution prevention management system at your facility, what are the steps? It's really easy, and that's what we always say. Start by creating a pollution prevention management system before you make any big changes. Of course, you have to have the management commitment. You have to have chair or leader to lead this effort, and then you have the team. And then you start with the screening phase, and you need to establish metrics, identify the priorities, what waste stream you would like to start with, and then evaluate your ideas, followed by the assessment. Then you need to collect data, draw flow charts like the ones I showed you at the beginning. This will actually include the materials balance, energy balances, and mass balances. And then the last one is to implement. And as you see, I always write this because implementation is the heart of the pollution prevention project. Implementation is where you see the results of what you did. And always we also include in our plan, monitoring plan, how to measure the savings. We do this most of the times, how to monitor the savings. And now the last thing I want to conclude with is now we have seen big investments in some recommendations. So what we really tell people to do is start with no cost, low cost, monitor savings, see and measure how much money you saved, and then move to the next step, which is implementing the medium cost and then implement the high cost. So we move from no cost, low cost to medium to high cost. I think just to leave time for David, I will just stop here and thank you very much. And if you have any questions.
Thank you so much, Dr. Salam. We will take questions at the end for time's sake. I'll go ahead and turn the platform over to David.
Thank you so much. I think this stuff is really so. I love the part where you get to use your creativity to really make some of these implementations. And so I'm going to talk with you a little bit about the other side of this, which is the really fun side where you get to make and save a lot more money. So in the intro, you heard a little bit about who I am, a little bit about my background. I own a manufacturing company. I'm the founder there. And in my day job, I get to help small businesses be more successful. And it's really exciting when I get to do things like this, where I get to talk about where my day job and where my passion for manufacturing intersect. And I'm going to bring you today an example from my company, and really source reduction is what I count as a competitive advantage in my business. So first, I want to tell you a little bit more about the center that I run at ECU. This grant, I'm a co-PI, and there's actually two centers involved here. The center that I run is called the CRISP Small Business Resource Center. So our mission is to provide the best practices and proven knowledge required to start and sustain enterprises in Eastern North Carolina. So basically, we're doing things to help small businesses grow in Eastern North Carolina. And those of you who are familiar with the definition of small business, it's fairly large businesses as well. So the SBA generally defines that as about 500 employees, which is a fairly sizable operation. Some programs that we do a lot of student consulting where we place our classes with clients to help them in areas like strategic planning, small business management, family business succession planning, human resource management, and then there's some other technical classes that we place as well, like writing. So last year, our students did about 34,000 hours of no-cost student consulting, which is a huge impact to our companies. We have a rural accelerator program where we take small businesses. Many are small manufacturing or food manufacturing type businesses, and we help them grow and reach global markets through that program. So thinking about strategic positioning, marketing, and kind of their brand position in the marketplace. We have a really cool shopping festival coming up on November 11th called Shop Rural Day. So if you produce a product, and especially if you're in a rural community, this would be a really great opportunity for you to participate and live pitch your product or service if you're going directly to the consumer. So this is really popular. We took this concept from some companies that were doing this in China, and I think it's going to apply really well to the U.S. market as well. We also offer other specialized workshops, including a one at 9 a.m. tomorrow that's around the new OSHA temporary standards that have been put in place. That one is, I will, at the end, when I have access to the chat, I will drop that in the chat box as well. So I actually can't see the chat right now, but I don't mind if you stop me during with any questions if you have something that's really pressing. So, you know, a lot of today we talked about there's no cost solutions. There's some that have a cost, and then there's some savings that have a cost, and those costs may be variable or temporary, or variable or fixed on either side. So the most obvious though is where you make a fixed investment in something like one of those new HVAC units or a boiler. And then you get variable savings off of that implementation each time you run a process or each time you run a batch. And so that's really common. And you can think about that as payback term in terms of years or in terms of units as well. In the example that I'll give today, we'll talk about payback in terms of units. But you could also have the flip of this. So you could have maybe a process that may cost a little bit more on each individual run, but you might have a big fixed cost savings. In other words, you might be able to sell a piece of equipment and move that over to a more variable cost structure, and thereby you have a savings there as well. You could have some of these both combined. So you could have a new procedure that you implement that would cause a variable savings, and it might be able to free up some equipment that you might be able to sell to bring in some cash as well. So there's some combination of this, and it's not as simple as just thinking about we make an investment in something and we get a payback over time. That can be the case, but there can also be times where that's not the case and it's a little more complicated. When I hear about cost savings, usually I hear this in terms of income statement. And I think most of you will, if you think about it, this is mostly what you've heard about. We make something that reduces waste or reduces pollution, reduces materials that we're using, and that's going to give us a reduced cost, which is going to have a great impact on our bottom line, or in many cases on our gross profit as well. But the income statement isn't the only place where we see those effects show up. You will also see effects on your balance sheet and on your cash flow statement. And many times, especially for smaller companies and smaller rural companies, that cash flow impact can have just as big of an impact as the income statement impact. And many times there's a barrier to implementation caused by the cash flow. So let's talk about that a little bit today as well. When you see the effects on your balance sheet, A lot of times you'll see those effects in the asset category. So if you're investing in new equipment, you will see that show up as an item on your balance sheet. This may strengthen your balance sheet depending on the amount of debt or equity that you use to fund that new equipment, or it may weaken your balance sheet. So having the right mix of debt and equity to fund changes is important. Some of these changes may require borrowing, and some may require use of funds that you've kept, so transfer of cash over to new equipment, or it may even require, at smaller companies, direct injection of capital or going out for capital raise for very big changes. So I've worked with companies in the past that have needed to section off portions of their plant and put in walls, and things like that are definitely new asset changes that will affect the balance sheet. And many times borrowing and equity will have that effect, will have an effect there as well. There are changes that you can make that would have effects on inventory or inventory holding levels. Some of your changes, especially if they're in product in nature, may cause inventory obsolescence as well. So you might increase waste stream in one area or waste in one area to decrease it in another area. So making sure that you have a large enough decrease in waste to cover the increase in waste and inventory happens as well. And you can also have a cash decrease associated with implementation, and that could affect your ability to make other changes in the market or invest in other areas of your business. So you have to take opportunity cost into account as well. If you borrow to invest in these asset changes, then you're going to have to perhaps limit borrowing in other areas of the business. You also have to pay interest based off of that. So not only do your changes have to have a positive impact, they have to have a positive impact that overcomes the increase in your interest rate as well, or in your interest payment. So you could also have a change in suppliers potentially, and that could result in a change of supplier terms. So if you're going to use a new supply, you may have to bring in a new supplier. That new supplier may not grant you the same credit terms as your previous supplier, and that could have a big impact on your cash flow of the business as well, as we'll talk about in a minute. And then, of course, on the equity side, you just really have to be careful of that right mix of debt and equity so that you're not moving too far away from industry standards. The income statement is the most obvious, but what's not often talked about is how some of these changes may impact your sales. So we talk a lot about cost reduction, but a lot of these things have really good positive impact. If you're selling direct to consumer, that story may really matter to the consumer. If you're selling business to business, the business that you're selling to may have targets for waste reduction, and they might want to use that story with their customers. So that positive press can really drive sales, and not just the positive press, but if you really have an eye for designing the best solutions for your customer and your very end customer, then many times you can make changes that will actually increase their value proposition and make you more sales. And I'll give you an example of that in my company near the end. Cost of goods sold, it's obvious that many of these changes are going to affect your cost of goods sold. It's going to change your perhaps how much labor time you're spending. It may increase labor time to decrease materials costs. You may have materials cost changes, and many of the changes we talked about are related to manufacturing overhead. But the mix of those may change as well, and that may change things like your hiring practices, who you need to hire, how many people you need to hire, who your material suppliers are, your batch order size. It's not quite as simple as just your cost is reduced as it relates to materials. That has an effect, could have an effect on other parts of your business. And then, of course, if you're making capital investments, depreciation expenses may come into account, as well as other logistics changes and interest expense changes that may come about too. Probably the most important for small companies and one of the most often overlooked is the effect that some of these will have on cash flow. It's not just enough to make a decision where you're going to save on costs. It also has to be able to happen by the business's cash flow. And those cash flow changes are of course, operating, investing, and financing changes. So keep in mind that some of these changes that you're accounting for on your income statement are non-cash changes. So those changes could be changes to depreciation. That might have a negative impact on your income statement and on your net income, but it might not have an effect on the cash flow of the business. So it's important to look at both of those statements. We already talked a little bit about inventory changes as well. So if you're holding less inventory, obviously that's a positive for cash flow. If you're holding obsolete inventory or an increase in inventory, that of course has a negative impact. We talked about payables on the balance sheet as well with the new suppliers. So obviously investing activities, there may be changes to the types of equipment that you have, and that could be a positive or a negative depending on if you're able to sell equipment because of a new process or you're able to bring on a new piece of equipment. And then of course, financing, you have to figure out how you're actually gonna pay for this implementation and where that cash is gonna come from for the implementation. So here's a interesting list of some things that you might not have thought about, but that the solutions can impact. So inventory holding, of course, your labor hours, bulk order discounts, machine hours, potentially quality control and your defect rates. So you have to decide, what level, if a change is going to affect your defect rate, what's acceptable. Your batch testing requirements may change based off of an implementation. And then you always have, you may have increased waste in other areas that you have to account for as well. So obviously making sure there's a net benefit is really important. But there's some benefits that we don't often take into account too. So, better meeting customer needs, having that beneficial PR, and you may have changes that might really increase your employee productivity. So if a process is easier on them, I think about the example that we went through with washing. So if a employee doesn't have to go and switch valves 10 times a day, and it's around their hot equipment, that might make their job a little bit better and might make them a more productive employee. That stuff's really hard to measure, and it's really hard to relate directly back to those changes that you made for waste reduction, but they may be there. So keep an eye out for some of the more non-obvious as well. So at my company, I make a product for the water sports industry. And I could go on about this all day because it's a real passion of mine of how you make solutions that are better for the customer and better for the company. But to give you an idea, this kind of source reduction is a competitive advantage for my business, and you can have an idea for that in cost. So sales price for my product, average tickets around $15,000. The business sells directly to the consumer. My closest competitor, their rate is around $60,000 to $70,000 for their average ticket. And there's no difference in function between our products. All of the difference is driven by being able to reduce waste and in my company's system. And I'll give you one quick example. I could give you dozens of examples, but this one's really easy to understand. This is a wheel. This wheel has two bearings that are pressed in on each side, And originally this was water jetted on the outside, milled on the inside, and has 4 holes drilled in. And it was really easy to water jet that center hole because you could just put the water jet on it, let it run, and then press fit the bearings into place. Well, what we found out is that that bearing's not going to stay because of the pressure for the press fit, and retainer plates have to be added on the outside to stabilize the bearing. So this was the first iteration in this system. In the second iteration, the wheel was milled completely, and instead of water jetting the center all the way out, we left a little picture it almost like a washer inside. There's a space in the middle that the bearing was able to rest on to keep it stabilized, so we didn't have to use those retainer plates anymore. So we also for half of our wheels, we were also able to reduce those 4 bolts that bolted the system together. So the 4 retainer plates, each one was about $10. There's 4 on each unit. It's about a $40 savings. The 4 fasteners on one side was about a $5 savings. There was a reduced assembly time as well that came into place. And then there was less wasted material, but that cost was pretty negligible. There was also a cost for design modifications. We had to go in and of course, program the mill to do the new job. And then we had a redesign of an outer bushing as well, because now that the bearings were set further apart and not press fit as deep into the material, we had to redesign another bushing. And that was fairly simple. And then we had obsolete inventory of those retainer plates that we were no longer going to need. And actually in the picture here, this is actually an iteration 2 wheel, even though it has the retainer plates on it. Those are just some spare retainer plates. So there was it's pretty easy to calculate the break even in number of units here. I want to take us to so here's the result of what happened. So there's about 450 in implementation costs and a $50 savings per unit, or about 9 units. And for my company, that's pretty significant. But it was also better for the end customer. Here's some other minor considerations that for me didn't make a huge impact, but at your company, you might want to think about some of these. So the availability of the mill versus the availability of the water jet. As you add more product lines, you have to keep some inventory of the old stock keeping units for the customers to be able to use. So there was an increase in inventory holding that happened there. This one happened to be a more reliable method, but reliability, when you change anything on the product, is going to change somewhat. So this increased reliability. And then we actually had some reduced shipping weight. That was pretty minor for this change. And then we figured out not only could we do this better, there were a lot of things we could change that would really have positive impact for the customer. So this wheel on the right, we went back to water jetting the center, and then we went to a commercial off-the-shelf application for a hub and spindle. And what that allowed us to do was open the design up for better maintenance. I don't really have time to get into how that worked, but we were able to have a much easier maintenance for the customer, and we actually redesigned the product in a number of ways so that there was a lot more reliability and a lot more of the things that the customers really wanted in the end. So that included redesigning another what we call our carrier unit that uses smaller wheels. We made those wheels the same thickness as our large wheel, and we used the waste material to redesign that carrier system to use the waste that comes from these wheels. So that center portion, there's actually 2 wheel types. That center portion was able to be used on the new wheel, and then the corner pieces, because this is cut out of a sheet, The corner pieces were able to be used for smaller wheels as well. So material utilization increased by about 30%. So the off-the-shelf hub was a lot easier to use. So that cost actually increased by about $40. So reduced material cost by utilizing all of these wheels from the existing material and not having to order a different size sheet comes out to about $250 per unit. Production costs moved back over to water jet, and this is just an easier wheel to cut out. That was saved us about another 40. We did have some design modifications, 500s total, not just for the wheel. The entire system redesign cost us about $500. So this broke even in about 3 units. So this one was really a no-brainer. On average, about 125 material costs per wheel and 75 production cost reduction. So that was pretty cool. The real value here, though, really had nothing to do with the materials. We were able to go back, and of course the savings was great. We were able to increase our price by about 4% because we felt the product better met customers' needs. We still offer the previous wheel design and product, and we have only had 1 sale of that product line. All other sales have been with the new design. It was a first in the industry and really received a lot of attention from a lot of the professional users. Customer maintenance decreased about 50% annually, so customers are thrilled with it. The redesign really does a lot of good things for the customer, and sales increased substantially because of that. So the improvements aren't just, the big takeaway here for me is think about this holistically as your entire business, how it could affect each part of your financials, how it could be a sales driver, and constantly have that mindset for improvement on your product and around your processes to produce the product, to think about how it's going to better serve your company and your financials and the end customer. This is my contact information. I think we saved just a few minutes to have Q&A.
Thank you, David. That a lot of information there. There we go. Excuse me just a second while I get things rearranged here. There we go. So during David's presentation, we did have a question from Miguel for Dr. Salam. He did respond in the chat box, but I didn't know if we needed to open up that to any further discussion from Dr. Salam. If not, we can move on to the next question. Okie dokie, we'll just move on to the next question then. So another question, this would be for David. For those that don't have an MBA or a business degree, can you recommend a good written source to learn the essential cost benefit financial concepts that we're talking about today?
Yeah, I mean, really, so there's 2 parts of it. There's the learning the financial aspects, and then there's the creativity and how you find the solutions. Dr. Salam may be a better person to talk about how you develop that skill for finding the potential solutions. I'll kind of flip it to, I think YouTube really has a lot of valuable resources related to learning about those financial statements. And so, there's some basic courses. There's actually a lot of them that are pretty good. Basic courses on YouTube on using your financial statements for decision making. Once you're kind of familiar with your line items and your 3 financial statements, then you just think about the impact that when you make a change, think upstream a little bit to how is this going to affect each area of the production line, and if I'm making a change to the product, what's each change going to be, and then you kind of have to step back and think about your knowledge of the financial statements and what impact it'll have on each one. So it's not a great answer, but I think you break that into two parts. You learn the financial statement piece and you learn the creativity piece, and then try to bring it together.
Excellent. For the person that asked that question, again, David's email address will be available to you if you have any further questions that you want to reach out to him about. We'll be happy to answer. Any of us will be happy to help you find the resources you need for the concepts that we're talking about today. So with that, are there any other questions from anyone? If anybody wants to unmute, ask their questions, or drop it in the chat box. We are right at 4 o'clock. But I just want to make sure that we're all good on the questions.
The financial statements for dummies book is also good, Paul. If you learn better by reading, the For Dummies book is a really good starting point.
Those are always really great books.
Yeah.
Thank you for your answers. Appreciate it. This is Paul.
Thank you, Paul, for joining us today. Okay, so with that, I'd like to again thank our speakers today, David, Dr. Salam, and each of you for taking your time out today to join us. Our next event will be the final event in the mini-series, will be December 2nd, again from 3 to 4 p.m. Eastern Standard Time. So go ahead and mark your calendars and just be on the lookout for an email from me to announce our next topic. And other than that, hold on a second. Is there? Okay, good.
Yes.
Just making sure that we're ready. Oh, okay, I see.
Quick question before you go. Quick question about the PowerPoints, the presentation, stuff like that. Question came about sharing it. I believe you do send it to all attendees, right? Or at least give them a link to the PowerPoints and the recordings.
Correct. So if you are wanting access to our university's shared OneDrive, again, you just need to reply to the email that I will be sending out right directly after this event, and I will send you a link to that shared OneDrive. Again, I just want to reiterate that we have been having some issues with government and organizational email addresses. So if we are finding that we're having issues accessing that folder through that email address, you may want to share like a Gmail or another private email address with me, and we can try accessing it that way. If we're still having problems, I will go to the ends of the earth to make sure you get this information. So please just bear with me, as I have no control over the institutional settings. So otherwise, if there are, I'm sorry.
And I just dropped in the link to the webinar tomorrow, the OSHA webinar that I talked about in my intro.
Perfect. Thank you so much, David, for that. Okay. So if there are no more questions, we'll go ahead and close up today, and we hope that you have a safe and healthy weekend ahead. Thank you so much for joining us.
Thank you.